My name is Hans, Head of Technical Marketing here at Quali, and for today's Chalk Talk session, we're going to talk about shells, which are the building blocks of cloud sandboxes. So because they're the building blocks of cloud sandboxes, I want to talk about what they are, a little bit of how they work, and why they're so cool. So we know that in Cloud Shell, we can build really powerful application and infrastructure blueprints that consist of a high mix of physical, virtual, or cloud components, and we do that just by dragging and dropping these components into our blueprints. We might build a blueprint that has something like a physical switch and Apache web server and a traffic generator and a database backend in our blueprint. All of those resources are built on shells. They're all built on shells. And shells define two very important things. The first is the data model. So they define the data model for each of these resources, which really defines the structure and the attributes of each of those resources. The other thing that shells define is the automation for each of those resources. Defines the automation for each of those resources, and we know that the blueprint gets deployed as a sandbox. And so when we deploy a blueprint into as a sandbox, each of those resources gets deployed into that sandbox, and the automation that is used to do that deployment is based on the kind of shell that each of those resources is based on. So, our switch gets deployed in here, our web server, everything. So our switch might be a specific Cisco switch or something like that. And so it would be built on a Cisco switch shell. Now, if that switch were something like a virtual switch or a VNF component, then it might be built on some other kind of shell, which might be, a virtual switch shell. Similarly, our web server is going to be built, if it's an Apache, it's going to be based on an Apache web server shell. Our traffic generator might be based on an Ixia traffic generator shell. Our database might be based on a MySQL database shell. Now, each of those shells is going to implement, like we said, the orchestration, the automation commands for each of those components. And they might have specific automation commands for that type of resource. Cisco switch might have some specific switch-related stuff. Web server shell might have some specific web server-related stuff. Traffic generator might have something like start traffic, stop traffic, that sort of thing. But what's really cool is that all of the shells are going to implement common orchestration commands. So shells give us a way to define a common set of orchestration and automation commands that are common to all types of resources. Some of the important ones are things like setup, teardown, and save and restore. So when we do this deployment of the blueprint into a sandbox, we're going to run the setup automation. And in that way, the orchestration that happens in our sandbox can just go and call the setup automation for each type of shell. Now, a Cisco switch is going to be initialized and set up differently than an Apache web server or a MySQL database. Similarly, if we want to do something like if we want to snapshot our entire sandbox and save it so we can restore it at a later time, we're gonna call the save automation and command for all of the resources in that sandbox. And in that way, each resource is going to implement that save command in a way that is unique to that type of resource. So, our Cisco switch, when it does a save, it might save the configuration to some TFTP file or something. Our Apache web server, let's say it's based on a VM, that VM might snapshot itself if it's, being deployed on vCenter or something like that. MySQL database might do some kind of database copy or something like that. And that can be customized and stuff, but the key there is that the shells give us a standard way to define orchestration across all types of resources. The other thing that is really important to note, and it is regarding the data model, all of the shells are backed by and based on the industry standard Tosca and backed by YAML files. So that gives a kind of industry standard way to define the data model for each of these shell resources. And since it's based on something like YAML, it can be easily, you can do configuration management on it really easily. So because of the way that shells are kind of defined in this really modular way, and this common way of defining orchestration across them, gives us a really reusable, repeatable, and reliable way of doing orchestration. So that's why shells are so cool. Now, I want to talk now about a special kind of shell. We call these apps. Apps are, you can think of them as really special shells. Okay, I didn't talk a lot about our little back-end application here, but this back-end app gets deployed into our sandbox. But it gets deployed as an app because it's an application. And apps really can be thought of as kind of like compound shells. They really have three components. Okay, the first component is what we call the deployment path. And that really just defines where the VM gets deployed. So all apps get deployed on a VM, and that VM can be deployed on a particular platform. So it might be VMware vSphere, or AWS, or Azure. Okay? Now, when an app gets deployed, that VM gets deployed in our sandbox. So our sandbox, this app server gets a little VM. Okay? Now that VM, depending on what platform it is deployed on, is based on a particular type of shell. So if we're deploying onto AWS, for example, some AWS VPC, then our VM that gets deployed is going to be based on an AWS EC2 shell. And that shell, again, just like any other shell, is going to have some shell-specific stuff. So for a VM, it might have, power on, power off, reset, stuff like that. But it's also going to have all of the common orchestration commands like setup and tear down, save and restore, and other things like that. Now the image defines the actual application image. So depending on what platform we are deploying our app onto, if it's vSphere, it might be something like a VMDK file. If AWS, it might be an AMI, etc., etc. Now, the image gets deployed as a resource. So in our sandbox, we get a little app there. The app is hosted on the VM. Okay, that app is also based on a shell. So in this case, with our little custom backend application server that we've got there, it might be based on a custom shell that we've created, maybe something called my app shell. Again, it's going to implement all those standard orchestration commands as well. Then the last piece is the configuration. After we deploy an app onto a VM, we want to do that post-configurate, run those post-configuration commands. And then there's two ways to do that. One is by running Python scripts, and the other is to run an Ansible playbook based on our native integration with Ansible. So that is going to give you a way to do all that post-deployment configuration on your application that gets deployed into your sandbox. So that's apps, really special kinds of shells. So talked about shells, talked about apps. Hope that gives you a sense of kind kind of how shells work, what they are, why they're so cool, and really why they are the fundamental building blocks of sandboxes.